Question 1. Given the circumstances of a commercial building exhibiting frequent HVAC cycling and occupant complaints of inconsistent temperatures, Mr. Patel suspects duct leakage. What diagnostic approach should Mr. Patel prioritize to accurately locate and quantify duct leakage? A. Conducting a blower door test on the building envelope only. B. Using a duct blaster test to pressurize the duct system and measure leakage. C. Measuring static pressure at the HVAC unit supply and return with manometer. D. Checking thermostat calibration and programming settings. Answer. Correct answer. B. Explanation. Using a duct blaster test is the most precise method to pressurize the duct system independently of the building envelope and measure air leakage rates quantitatively. Blower door tests assess the whole building envelope's air tightness but cannot isolate duct leaks. Static pressure measurements reveal pressure drops but do not quantify or locate leaks. Thermostat checks affect system operation but don't address duct integrity. Accurate duct leakage measurement is critical for pinpointing inefficiencies and reducing energy waste in ductwork. Question 2. In the context of load calculations for a new residential HVAC installation, Alvarez notices the manual J estimate significantly underestimates cooling loads compared to actual peak demand. Which factor is most likely causing this discrepancy? A. Overestimating infiltration rates in manual J input data. B. Ignoring latent loads from indoor humidity sources. C. Using incorrect solar heat gain coefficients for windows. D. Applying manual D duct sizing criteria improperly. Answer. Correct answer. C. Explanation. Solar heat gain coefficient AE directly impact cooling load calculations by estimating heat transmitted through windows. Using incorrect or outdated CJC values leads to underestimating solar heat gain, causing load under prediction. Infiltration overestimation would increase load, not decrease it. Latent loads are critical but less likely ignored since they are standard inputs. Manual D relates to duct sizing, which affects airflow but not the initial cooling load estimate. Question 3. ISTA is auditing a building's combustion appliances and detects elevated CO levels near furnace vent. From safety and energy efficiency perspective, what is the best immediate action ISTA should recommend? A. Sealing all visible cracks around the furnace cabinet with foam sealant. B. Shutting down the furnace and scheduling professional combustion appliance inspection. C. Increasing the thermostat set point to reduce furnace runtime. D. Cleaning or replacing the furnace air filter. Answer. Correct answer. D. Explanation. A dirty or clogged air filter restricts airflow, causing incomplete combustion and resulting in elevated CO emissions. Replacing or cleaning the filter restores proper combustion conditions and reduces CO production. Sealing cracks around the cabinet does not address combustion quality. Shutting down the furnace is extreme without confirmation of appliance malfunction. Adjusting thermostat settings doesn't correct combustion and may reduce comfort. Question 4. From the perspective of energy modeling, when considering a retrofit of a building envelope with new insulation and windows, what is the primary limitation of using simplified prescriptive methods rather than detailed simulation? A. Prescriptive methods are more expensive and time-consuming. B. They cannot accurately account for dynamic interactions like solar gains and occupant behavior. C. Simplified methods require advanced software and modeling expertise. D. Prescriptive methods ignore building codes and standards. Answer. Correct answer. D. Explanation. Prescriptive methods do comply with building codes and are simpler, not ignoring them. However, they are limited by their static assumptions and often fail to capture dynamic phenomena such as solar heat gains, internal gains, and occupant behavior that detailed energy simulation can model. They are generally less expensive and less complex than full simulations. Thus, while useful for quick checks, they do not provide nuanced insight needed for optimal retrofit design. Question 5. When analyzing HVAC system data, ISTA observes that the measured airflow at the supply registers is significantly lower than design specifications. Considering ductwork and system operation, what is the most plausible cause? A. Excessive duct leakage causing pressure loss. B. Oversized HVAC equipment operating at partial load. C. High outdoor air intake causing system overpressurization. D. Thermostat setback reducing runtime. Answer. Correct answer. C. Explanation. High outdoor air intake can cause system overpressurization, which may reduce airflow to individual supply registers as the system struggles to maintain balance. Duct leakage usually causes air loss but would not necessarily reduce measured register airflow below design since leaked air bypasses registers. Oversized equipment may cycle more, but usually does not reduce airflow unless throttling occurs. Thermostat setback reduces runtime but does not affect instantaneous airflow rates. Question 6. Considering the evidence from recent audits, which principle best explains why increasing ventilation rates indiscriminately in buildings may reduce overall energy efficiency despite improving indoor air quality? A. Ventilation always reduces energy consumption by diluting contaminants. B. Increased ventilation raises heating and cooling loads by introducing unconditioned air. C. Ventilation systems have no impact on building envelope airtightness. D. Ventilation systems operate independently of HVAC equipment efficiency. Answer. Correct answer. C. Explanation. While ventilation improves indoor air quality by diluting contaminants, indiscriminate increases in ventilation rates introduce more unconditioned outdoor air, increasing heating and cooling loads and energy consumption. The statement that ventilation systems have no impact on envelope airtightness is true but irrelevant to the energy penalty caused by increased ventilation. Ventilation systems are closely linked to HVAC efficiency since they condition additional air, thus balance is critical. Question 7. As illustrated by a recent energy audit, Thompson finds that adding a variable frequency drive (VFD) to an HVAC system supply fan improves efficiency. Which factor primarily accounts for the energy savings? A. The fan runs constantly at full speed to maintain pressure. B. The VFD adjusts fan speed to match variable load demand, reducing power use. C. The VFD increases the static pressure in the ductwork to overcome leaks. D. The VFD eliminates the need for periodic maintenance. Answer. Correct answer. D. Explanation. Variable frequency drives save energy primarily by modulating fan speed to meet actual load demands, lowering motor power consumption compared to constant full-speed operation. Running constantly at full speed wastes energy. Increasing static pressure to overcome leaks is inefficient and not a benefit. VFDs require maintenance and do not eliminate it. Maintenance is still necessary for operation. Question 8. During an energy audit, Johnson notes that a commercial building's thermostat is frequently overridden by occupants, leading to erratic temperature control. What is the most effective strategy to improve energy efficiency without reducing occupant comfort? A. Installing programmable thermostat with lockout features and user education. B. Allowing unrestricted manual overrides to maximize comfort. C. Reducing HVAC capacity to limit temperature swings. D. Removing thermostats entirely and using manual fan controls. Answer. Correct answer. A. Explanation. Programmable thermostats with lockout capabilities prevent unnecessary overrides while allowing scheduled temperature control, balancing energy savings and occupant comfort. Educating users improves adherence. Allowing unrestricted overrides leads to inefficiency. Reducing HVAC capacity risks under conditioning. Removing thermostats causes loss of automated control, increasing energy waste and discomfort. Question 9. When faced with a building exhibiting elevated infiltration, Garcia plans to perform a blower-door test. Which of the following best describes the main purpose of this test? A. Measuring duct leakage independently from the building envelope. B. Quantifying building air tightness to identify infiltration-driven energy loss. C. Calculating the heating load of the building's HVAC system. D. Testing the combustion efficiency of heating appliances. Answer. Correct answer. C. Explanation. A blower-door test is designed to quantify the airtightness of the entire building envelope by inducing a pressure difference and measuring airflow through leaks, helping identify infiltration-driven energy losses. It does not measure duct leakage independently. Duct Blaster does, nor does it calculate HVAC heating load directly or test combustion efficiency. Understanding airtightness allows targeted air sealing to improve energy efficiency. Question 10. Under the assumption that a building's HVAC system is operating below design efficiency, is to new and suspects improper refrigerant charge in the vapor compression cycle? What impact does an undercharged refrigerant system have on performance? A. Increases evaporator coil heat transfer efficiency. B. Causes reduced cooling capacity and increased compressor work. C. Decreases compressor discharge pressure and raises cooling output. D. Improves system reliability and reduces energy consumption. Answer. Correct answer. C. Explanation. An undercharged refrigerant system typically decreases evaporator pressure, reducing cooling capacity and causing the compressor to work harder due to inadequate refrigerant flow. This leads to lower system efficiency and potential reliability issues. It does not increase heat transfer efficiency or cooling output. Reduced refrigerant charge worsens energy consumption and stresses equipment. Question 11. Under the assumption that an office building has high energy costs and occupant complaints about inconsistent temperature zones, is Davis suspects improper zoning of the HVAC system? What is the best initial step to verify this suspicion? A. Measuring static pressure differences across duct zones. B. Performing temperature mapping of different zones during peak operation. C. Checking thermostat calibration in each zone. D. Inspecting the duct insulation for damage or leaks. Answer. Correct answer. B. Explanation. Temperature mapping during peak operation allows direct observation of temperature variation between zones, confirming improper zoning or balancing issues. Static pressure measurements alone don't reveal temperature differences. Thermostat calibration checks accuracy but won't detect systemic zoning problems. Duct insulation issues affect efficiency but not zoning directly. Temperature mapping is key to diagnosing efficiency. Question 12. When analyzing the psychrometric chart for a retail store, Staccato observes that the indoor air's enthalpy is significantly higher than outdoor air, despite mechanical cooling being active. Which factor is most likely causing this phenomenon? A. Excessive infiltration of warm, humid, outside air. B. Oversized HVAC equipment causing short cycling. C. Inadequate ventilation rates reducing latent load removal. D. High internal loads from lighting and occupants. Answer. Correct answer. D. Explanation. High internal loads from lighting, occupants, and equipment generate sensible and latent heat, raising indoor air enthalpy even when cooling is active. Excess infiltration would increase outdoor air influence but usually is balanced by mechanical cooling. Oversized equipment causes cycling but not increased enthalpy. Inadequate ventilation reduces fresh air, but latent loads may accumulate internally, making internal heat loads the most direct cause. Question 13. In the context of combustion safety, Mr. Ahmed detects elevated levels of nitrogen dioxide known near a gas furnace during an energy audit. What should be Mr. Ahmed's primary concern? A. No indicates poor ventilation and potential health hazard. B. No levels correlate with high furnace efficiency. C. Elevated no suggests the furnace is undercharged with refrigerant. D. No detection is unrelated to combustion processes. Answer. Correct answer. A. Explanation. Nitrogen dioxide is a toxic byproduct of incomplete combustion and poor ventilation. Its presence indicates combustion appliance safety risks and potential occupant health hazards. No does not correlate with efficiency or refrigerant charge, which relates to refrigeration cycles. It is a key indicator for proper combustion, ventilation, and appliance inspection. Question 14. Given the circumstances of a multi-story building, is Roberts is reviewing energy bills and suspects stack effect is causing significant infiltration in winter. What building feature should she inspect to confirm this? A. Air leakage of window and door seals on upper floors. B. Duct leakage in the HVAC return system. C. Condition of insulation in the attic. D. Thermostat set points on each floor. Answer. Correct answer. A. Explanation. Stack effect causes warm air to rise and escape at upper floors through leaks around windows and doors, drawing cold air infiltration at lower levels. Inspecting upper floor leakage points confirms stack effect. Duct leakage affects HVAC efficiency but is unrelated to stack-driven infiltration. Insulation affects heat loss but not air movement caused by stack effect. Thermostat set points don't influence infiltration. Question 15. According to recent studies, Istasing is tasked with improving indoor air quality while minimizing energy use in a commercial building. Which ventilation strategy best balances these goals? A. Increasing constant ventilation rates regardless of occupancy. B. Installing demand-controlled ventilation based on CO's sensors. C. Completely sealing the building envelope to prevent air exchange. D. Using natural ventilation exclusively during all hours. Answer. Correct answer. C. Explanation. Sealing the building envelope reduces uncontrolled infiltration, minimizing energy loss while allowing mechanical ventilation to provide controlled fresh air. Increasing constant ventilation wastes energy when occupancy is low. Demand-controlled ventilation adjusts air based on occupancy but requires proper system controls. Natural ventilation alone is weather-dependent and inconsistent for HVACR energy goals. Question 16. While examining the consequences of improper refrigerant charge, Newer notes an HVAC system with high superheat and low subcooling values. What is the most likely operational issue? A. The system is overcharged with refrigerant. B. The system is undercharged with refrigerant. C. The expansion valve is stuck open. D. The compressor is malfunctioning. Answer. Correct answer. D. Explanation. High superheat and low subcooling often indicate insufficient refrigerant flow due to compressor malfunction causing inadequate pressure differential. Overcharge leads to low superheat and high subcooling. An expansion valve stuck open would lower superheat but not cause this pattern. Compressor failure directly disrupts refrigerant circulation, causing abnormal readings. Question 17. From the perspective of building science, Mr. Brown is analyzing how thermal bridging affects energy performance in a retrofitted commercial building. What best describes the impact of thermal bridging? A. It increases heat loss through conductive paths bypassing insulation. B. It improves energy efficiency by enhancing heat transfer. C. Thermal bridging has no measurable impact in well-insulated buildings. D. It primarily affects air infiltration rather than heat transfer. Answer. Correct answer. B. Explanation. Thermal bridging refers to conductive materials that bypass insulation, increasing heat loss and reducing overall energy efficiency. It does not improve efficiency or have negligible effects. It mainly affects conductive heat transfer, not infiltration, which is air leakage. Addressing thermal bridges is crucial to optimizing envelope performance. Question 18. Taking into account airflow measurement techniques, Wilson is tasked with verifying supply air delivery at diffusers in a large retail space. Which tool and method should she use for the most accurate measurement? A. An anemometer to measure air velocity at diffuser openings and calculate flow rate. B. A manometer to measure static pressure in supply ducts. C. A multimeter to check electrical current on supply fan motors. D. A blower door test to measure building envelope leakage. Answer. Correct answer. B. Explanation. Measuring static pressure with a manometer in supply ducts allows calculation of airflow when combined with duct characteristics. An anemometer measures velocity but is less accurate in turbulent diffuser flows. Multimeters measure electrical properties unrelated to airflow. Blower door tests measure envelope leakage, not supply airflow. Question 19. Demonstrated by recent energy audits, Sister Lopez finds that frequent short cycling of a heat pump system leads to poor efficiency. What is the most effective solution to reduce short cycling? A. Increasing thermostat set points to lengthen run times. B. Installing a larger compressor unit. C. Adding a thermal storage tank or buffer to increase system run times. D. Sealing duct leaks to improve airflow. Answer. Correct answer. D. Explanation. Sealing duct leaks improves airflow and system pressure balance, reducing cycling caused by pressure drops and inadequate delivery. Increasing thermostat set points can cause discomfort and energy waste. Larger compressors may exacerbate cycling if not matched to load. Thermal storage tanks improve cycling but are complex and expensive compared to duct sealing. Question 20. In light of recent developments in emerging technologies, Evans is considering installing variable refrigerant flow (ERF) systems in a multi-tenant building. What is a major advantage of ERF systems in energy auditing context? A. They provide fixed capacity heating and cooling with simple controls. B. ERF systems enable precise zone level temperature control with improved efficiency. C. They eliminate the need for regular maintenance. E. ERF systems increase energy consumption due to variable speeds. Answer. Correct answer. B. Explanation. ERF systems modulate refrigerant flow to match zone loads, precisely improving comfort and energy efficiency by avoiding oversizing and cycling. They have complex controls and require maintenance. Fixed capacity systems lack this adaptability. Variable speeds reduce energy consumption by matching load demands, not increasing them. Question 21. In the modern context of an industrial facility audit, Mr. Wilson detects unusually high return air temperatures compared to supply air. What is the most likely cause of this temperature differential issue? A. Excessive infiltration causing warm air mixing in the return. B. Inadequate return air duct sizing resulting in poor airflow. C. Dirty evaporator coils reducing cooling capacity. D. Faulty thermostat calibration causing false readings. Answer. Correct answer. C. Explanation. Dirty evaporator coils impede heat transfer, causing the cooling system to underperform and resulting in high return air temperatures. Excessive infiltration mixes outdoor air, but typically raises supply air temperature. Inadequate return duct sizing affects airflow volume but doesn't directly cause temperature spikes. Thermostat calibration influences control, but not measured air temperature in ducts. Question 22. Given the circumstances where Iswang is assessing a building's combustion appliance, she notes high stack temperature but low flue gas oxygen levels. What does this combination most likely indicate? A. Excess air is too high, reducing combustion efficiency. B. Incomplete combustion due to insufficient air supply. C. The burner is operating optimally. D. Flue gases are being diluted by infiltration air. Answer. Correct answer. D. Explanation. High stack temperature combined with low oxygen often suggests dilution of flue gases by infiltration air entering the chimney or flue, which lowers measured oxygen. Excess air would show higher oxygen. Insufficient air causes high CO and incomplete combustion, but usually higher oxygen is detected when air supply is insufficient. Optimal operation would show balanced oxygen and temperature. Question 23. The fundamental question is why Mr. Lopez's blower door test results show significantly higher leakage rates in the winter than summer. What best explains this observation? A. Seasonal variation in wind speeds affects leakage measurement. B. Stack effect causes greater pressure differences in winter, increasing infiltration. C. HVAC equipment cycling causes inaccurate blower door readings. D. Thermostat settings influence building envelope tightness. Answer. Correct answer. B. Explanation. Stack effect, driven by temperature differences between indoor and outdoor air, is stronger in winter, causing greater pressure differences across the envelope and increasing infiltration rates measured by blower door tests. Wind variation affects pressure but is accounted for during testing. HVAC cycling doesn't impact blower door pressure control. Thermostat settings do not affect envelope tightness. Question 24. Based on the information from recent audits, Singh recommends adding attic insulation in a residential retrofit. Which of the following best describes the key benefit of this upgrade? A. Reduces heat transfer through the roof assembly, lowering heating and cooling loads. B. Increases building air tightness by sealing all leaks. C. Improves HVAC equipment efficiency by reducing duct leakage. D. Eliminates the need for ventilation in the attic space. Answer. Correct answer. D. Explanation. Adding attic insulation primarily reduces heat transfer through the roof assembly, decreasing energy loads for heating and cooling. It does not inherently improve air tightness or duct leakage and does not eliminate the need for attic ventilation, which prevents moisture buildup and structural damage. Proper ventilation remains necessary regardless of insulation. Question 25. Taking into account energy audit procedures, Istakim wants to prioritize upgrades for a commercial building. Which approach best balances cost effectiveness and energy savings? A. Installing the highest efficiency HVAC equipment first. B. Sealing all envelope air leaks before upgrading equipment. C. Replacing all lighting with LEDs regardless of current condition. D. Upgrading controls and thermostats before addressing physical envelope issues. Answer. Correct answer. A. Explanation. Upgrading to high-efficiency HVAC equipment often delivers the most immediate energy savings, but should ideally be preceded or combined with air sealing. Sealing leaks is critical but might have a lower upfront impact than replacing inefficient equipment in some cases. Lighting upgrades and controls are valuable but less impactful than major HVAC improvements on energy bills. Question 26. Throughout the course of an energy audit, Ramirez finds the building's HVAC system cycling on and off frequently. What is the most plausible cause of this short cycling? A. Oversized equipment relative to the building's load. B. Insufficient duct insulation causing temperature swings. C. Incorrect thermostat calibration causing delayed response. D. Excessive outdoor air ventilation increasing load. Answer. Correct answer. B. Explanation. Short cycling is most commonly caused by oversized equipment, but insufficient duct insulation causes temperature fluctuations that can mimic cycling effects. Incorrect thermostat calibration can cause control issues, but not necessarily cycling frequency. Excessive outdoor air adds load, but doesn't cause rapid cycling without other issues. Question 27. In what way is Carter verify that an installed energy-efficient heat pump system is performing as designed? A. Comparing measured coefficient of performance, COP, under load conditions with design specs. B. Verifying refrigerant charge by pressure readings alone without temperature data. C. Observing runtime without considering indoor and outdoor temperatures. D. Measuring thermostat settings only. Answer. Correct answer. C. Explanation. COP comparison using both temperature and pressure data under load conditions provides a reliable assessment of heat pump efficiency. Pressure readings alone are insufficient without temperature context. Runtime observations without temperature consideration don't reveal system efficiency accurately. Thermostat settings alone are inadequate for performance verification. Question 20. Considering the evidence, what factors contribute most to inaccurate airflow measurements in a duct system during an energy audit? A. Using an anemometer in highly turbulent airflow areas near diffusers. B. Measuring airflow at the HVAC unit's fan inlet. C. Recording static pressure at multiple points along ducts. D. Employing calibrated instruments regularly. Answer. Correct answer. B. Explanation. Measuring airflow at the fan inlet can be misleading due to turbulent and non-uniform flow. Anemometers near diffusers may be affected by turbulence, but with proper technique can be accurate. Static pressure measurements help infer airflow but require proper conversion. Using calibrated instruments is essential for accuracy, not a source of error. Question 29. A common thread among successful energy audits is the systematic identification of building deficiencies. Mr. Stevens finds high humidity in a sealed commercial building. What is the most likely cause? A. Lack of mechanical ventilation causing moisture accumulation. B. Oversized HVAC equipment drying the air excessively. C. Excessive duct leakage pulling in dry outdoor air. D. Use of dehumidifiers throughout the building. Answer. Correct answer. A. Explanation. In sealed buildings, insufficient ventilation traps moisture, raising indoor humidity. Oversized equipment tends to reduce humidity by overcooling and dehumidifying. Duct leakage typically introduces unconditioned air, potentially drying or humidifying depending on outdoor conditions. Dehumidifiers low humidity, so their use contradicts high humidity. Question 30. How might one explain the energy savings observed after installing programmable thermostats in a large office building? A. Programmable thermostats maintain fixed set points regardless of occupancy. B. They reduce HVAC runtime during unoccupied periods by adjusting temperature set points. C. They increase runtime to improve occupant comfort. D. They override HVAC controls to manually adjust airflow. Answer. Correct answer. A. Explanation. Programmable thermostats save energy by reducing HVAC runtime during unoccupied periods via adjusted set points. Maintaining fixed set points regardless of occupancy would waste energy, not save it. Increasing runtime raises energy use. They do not override HVAC controls to adjust airflow. A control is via temperature set points.